Okay, go on to the basics. We're gonna start off with the real number line. Make a line, put 0 in the middle. We count upwards to the right. So 1, 2, 3, 4, 5, and keep them going. When we go to the left, we have the same thing, but they are now negative numbers. One and higher are called the whole numbers. They are the countable numbers. It's what we use to count. Integers. These include the whole numbers. Zero. And for a lack of a better way of saying it, the negative whole numbers. Like no decimals or anything like that. Then we have the rational numbers. Rational includes the word ratio, which means fraction. So integers count here. We can do like 4/1 still equals 4, but we can write it as a fraction. It includes fractions, like we were just saying. Or it can also include decimals that can be written as fractions. Right, so kind of like in this category, the decimals that you can write as fractions, decimals that end. Like, I don't know, 15.675892.3. It can be a long decimal, but as long as it doesn't keep going, it ends. We can write that as a fraction. Also in this category is sometimes unending decimals. And these are usually, I can't think of any that are not, Decimals that repeat. For example, like 1/3 is 0.33333333. And we're gonna write it as 0.3. And we put a bar over it. Talk about the bar in a second. Denominators with a 9 usually have a repeating one. This one is 0.444444. And we'll call it 0.4 with the bar. These are just examples, there's a lot more than these. 11 as a denominator has some interesting things. This one is 0.27272727. And it just keeps going. And when we write this shorthand notation, we put 27 with the bar over above. Yes. I'll pause and let Brett catch up. In case I've been going too fast. Yeah. That bar is called the repetition bar. And you'll notice we put it over a sequence that repeats. So that edge. That'll make me sad. Let's see if I can make a really big one. Show up. 1 2 3 4 1 2 3 4 1 2 3 4. That's the song of the count. So like that one. I just had 1 2 3 4 over 99999. That gave me 0.1234. All of those kept repeating in a sequence of numbers. So that's how we do it. Questions so far? This is the boring terminology shit. Yeah.
So what's I, do we do that to IQ?
We're not actually. I don't think you're gonna need to use it in this class, but. It is not a repeating number, it is an unending decimal that doesn't repeat. It's in the next category. It's like you knew what I wanted to talk about next. Well done. So those were the rational numbers. The next category that includes numbers like 5 are called the irrational numbers. numbers that can't be written as a fraction. These are your non-repeating, non-ending decimals. Pi is one of the most famous ones. You probably know it just as 3.14, but there is a whole lot more numbers. 159, blah, 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 it keeps going. Wait, 15, it might be 1529, I don't know. I don't know too many decimal places of pi. I know someone that had pi to 100 decimal places. Tattooed on the inside of his arm, spiraling outward. Yeah, he was a math geek. I know you probably think that's an insult, but I don't. I'm not gonna get a tattoo, that's crazy shit. There are other ones, E is a common one that shows up in nature. It's 2.71 and it's got more numbers that I don't know the rest of. But it shows up in physics and engineering and stuff like that a lot. It's also most square roots. Like the square root of 2 is 1.414 and it keeps going. Square root of 3 is 1.732 and it keeps going. These will show up a lot in our class, but we're gonna round. So we're gonna hit rounding in the next, I don't know, week or so, maybe even a day. Who knows?
Well, I'll let you know, keep up on it.
Ray's watching me. Oh no, they just met outside and just started talking about it. Right, they were just sitting outside. I'm like, what are you guys sitting down, right? He's our computer wizard over here. It's hilarious. Okay, so I'm gonna do another quick number line real quick, just to talk about some more stuff. So if you have a number line and they ask you to plot a point, like, let's say plot 1. On the number line. When they say plot, what they're asking you to do is locate the number and put a dot. A noticeable dot. I'm sure there's homework problems that have like plot a number, and so that's what they're asking you to do. They might ask you to plot other stuff, like plot 2/3. 2/3 is 2 divided by 3, so this is how fractions turn into decimals. We divide the top by the bottom. That ends up being 0.6 repeating. A lot of this is calculator work, but like at this point. You kind of eyeball it, we don't have it on that, we don't have it there, but it's like. 2/3 of the way, maybe I'll break this up into thirds and I'll go, okay, that's about. 2/3 of the way between 0 and 1. Negative 2.5. -2.5 is between -2 and -3. About halfway, -2.5. I want to do a negative number real quick because I want to tell you what absolute values are, but I want to make sure everyone's ready. Do we need more time to write what we got so far? So when we do absolute values, helps if you spell it right. Absolute has an E on the end of it, it's not the vodka. Absolute value, we will put vertical bars around whatever we're talking about, so like vertical bars around -2.5. What absolute value does is it measures the distance from zero. So if I come up here and I do negative absolute value of -2.5. Starting at 0, I go left. It's fucking really bright too. So if I go left 2.5 steps. I can get to absolute value of -2.5. So this would be 2.5. That's important to math majors, but everybody else, the way you remember absolute value is just. After calculations are done inside. Make it positive. Make that value positive. Is you ready for some more? All right, fractions. You mentioned fractions. How do fractions work? Fractions represent part of the whole. Is there anyone here that's never had pizza? This seems like a silly question. I've yet to have someone say, yeah, I've never had pizza, but you never know. I had someone in the morning class that had never seen Sesame Street, so didn't know who the cat was.
Wow.
That blew my mind. But you never know, every once in a while you get surprised by shit. Alright, so everybody knows pizza, we're gonna use pizza. There's always those wedges that are not the same thickness as everybody else, but we're gonna pretend. Those are all the same slices. Pretend they are all the same size. That's kind of important for the idea of fractions. Right, how many pieces of that pizza do you like to eat?
Many as they can.
On an average dinner, how many would that be? 4? We'll put Alfredo down for 4. And we'll give Alfredo the A. He's letter A. Spencer, how many do you like to eat? 5. Now, seeing as how I want some pizza too, I'll throw in my name for last. So you'll notice these add up to 12. 12 slices. So if we want to represent how much pizza we've eaten as a fraction. We put the partial value on top. And the total pieces on bottom. Now, I usually call them top and bottom because everyone knows what those words mean, but the real math jargon. For whoever asshole came up with this. Is numerator and denominator. Because everybody likes syllable, like 5-syllable words that are hard to fucking spell. So. Alfredo. Had 4 slices out of a total of 12 slices. Spencer. Had 5 slices out of 12 slices. David had 3 slices out of 12. We also have something called equivalent fractions. So Alfredo ate 4 of the pieces, and if we look at the pieces. And let's just say he was cutting it at home, he's like, I like one big motherfucking piece. I'll fold that bastard in half. Alfredo ate that part. And I could have had, like, that's 4 slices. I could have this over here as 4 slices and this over here as 4 slices. But I don't. I can also rewrite this, it looks like Alfredo, we can rewrite. As 1 out of 3. So 4/12 and 1/3 are equivalent fractions. Equivalent sounds like equal. And that's what it means. They have a word for taking. The bigger number and making it down to the smaller number. We call this, when we go from the bigger to the smaller value, simplifying. Simplifying a fraction. Simplifying, you might have also heard it as reducing. Is writing the larger fraction as a smaller one. Smaller equivalent one. So how do we do that? We write top and bottom. In terms. Of their factors. And factors are the numbers. That multiply to make it. And cancel out. Factors that appear on top and bottom. Has anyone seen Snowpiercer? So movie with the train and, or it's a TV show also. Train and all that, the world froze over. I mean, my wife was having me watch it, we're like on the second season. And I finally, like, it bothered me because it started snowing at the end of like season one. Like a little bit, and they're like, oh, the world's warming up. And I'm thinking. Where the fuck is snow coming from? Like, if the world froze over, all the ice came already, isn't all the ice of water that was in the sky fucking frozen and dropped out already? It didn't evaporate, the world is like sub-zero, there's no way it just like thawed and evaporated so that it could snow again. So I don't know where it's coming from. There's your short distraction from thinking about math problems. Things that make you go. So let's take a look at how we reduce Alfredo's fraction. So 4 can be written as 2 times 2. And 12 can be written as, this is 4 times 3. And I can write this as 2 times 2 times 3. There's a quicker way to simplify this, but I want to show like the full process. This is what's happening if you do it on your calculator. And your calculator does fractions, this is what it's doing. numbers that appear in top and bottom, we cancel in pairs. So like these two, I will cancel together. And I'll leave behind a 1. These two, I will cancel together and I will leave behind a 1. That dot means multiplication. The reason why we switch to dots, it's a shame that we just don't use it from like. I don't know, 3rd grade or 4th, whenever you start learning about multiplication. I don't know why we don't start using them, because as soon as you switch to. The very first non-arithmetic math, algebra. They start using dots because x is a common variable. So like we don't use the x. So on top, we have 1 times 1 and 1 times 1 is 1. On the bottom, I have 1 times 1 times 3 is 3. And that's what we get. There's a quicker way. You could recognize right away. And hopefully you know your multiplication enough to do that, recognize this is 4 times 3. And cancel there. Just canceling the 4s there, leaving behind a 1. And we're left with 1 over 3. The reason we leave behind a 1 is because it's not 0. Like notice if I just crossed off the 2s or the 4, I would have nothing left on top. I've seen students that are like future engineers calling it 0, like they done forgot basic. Simplifying. So we leave behind a 1. Any questions so far? Factoring isn't the most easiest task if you don't know like multiples, and let's face it, big numbers, but even like good mathematicians don't know multiples of. If you give me a large number, I would have to start figuring out slowly, piece by piece, what I can multiply it. So the way we find factors. Can involve. Testing with division. Prime numbers. So what's a prime number, you might ask? I know we're having fun, right? Prime numbers. Are divisible. Only by themselves. And 1. Divisible means no remainder after division. Or decimal after division. So these numbers start at 2, there's 2, 3, 5, 7, 11, 13, 17. 19, 23, 29, 31, and it keeps going. There's actually a neat. Procedure where you can find the prime numbers pretty easy if you have a big table of numbers. It's called a Rothsteiny Steve, I don't know, I'll show you guys over break. Cause I don't think most people are gonna care about it. But it's fun to see. Oddly enough, one. Is not prime. Nor composite. Composite numbers. Are also. Divisible by. At least one prime number. That. Isn't themselves. Maybe I should say evenly divisible. Alright, so like this can be a challenge, like, but there are some rules for the first few numbers. Like divisibility rules that are kind of neat. So we'll make a list of them on the next page, so that it makes it a little bit easier to do. Anyone need this longer? Good? Sure?
Yeah.
So divisibility rules. So. If it's divisible, this is gonna be like something that applies to everything I'm gonna say. If it's divisible by. We'll go with 2. The number ends. In a 0, 2, 4, 6, or 8. If it meets this criteria, we call this an even number. You can come in.
This is like previous class.
Yeah, it's the supplement. Of math practice for stats. Three. Is fucking magic. The divisibility rule for 3. If the digits. Add to a number. That is. Divisible by 3. The big number is also. This one you kind of see an example, I would think. So like, let's say we've got like 54,000,000. 369,000. And 12. I mean, we could, if we had a calculator, we could easily see that it's divisible or find that it's divisible by 3. What this says is add up all these digits. So this is a 9, this is a 9. 9, then those 3 add up to 27. Plus 1 and 2, that's 3 more. This adds up to 30. 30 is evenly divisible by 3. So this is evenly divisible by 3. That shit's magic. I don't know why that rule works, but it does. I bet if I really like stopped and thought about it, like use a lot of brain power on it for a while. Or probably Googled it because someone's already done this. But I don't want this like feel like cheating when you're a math teacher. This is a big number you're not gonna see in this class, so it was just an example of like. How about it could be like something you are gonna immediately go, I have no idea if you can divide that by 3. That's a quick test. Our next prime number is 5. So if we're divisible by 5, it ends in a 5 or 0. If it's divisible by 3, it's not prime. It's called a composite number. So it's a composite number. The next prime number was 7, but like the rules for 7 are fucking confusing. At that point, it's like easier to just try to divide by 7 with a like calculator, or even by hand if you wanted to do it by hand, the old fashioned way. Rather than trying to do something that's quick. The rest of these can be done quick, but another good one is 10. 10, it ends in a 0.
This class.
It's not the main course now. If you will, you can listen to shit while you're waiting. Or you can listen to me, whichever one you want. Alright, so let's try to factor. This is fun, let's try to factor. So when we say factor a number. Means write it out. In terms of its factors. Apostrophe goes right there. Let's try that big old fucked up number there, up there. I'm gonna keep dividing by 2 until I can't divide by 2 no more. So 54, 369, 12. Divided by 2. I can write this as 2. And 27,184,506. This ends in an even number, so. A 0, 2, 4, 6, or 8, so it means I can divide by 2 again. 14,592,253. I think maybe I made too big of a number to make, to just practically. But we'll find out. It doesn't end with an even number, so there's no more twos. We stopped testing twos. Now, this added up to where we can divide by 3, so this one's got to also, next one I'm gonna do is I'm gonna divide by 3. If I divide by 3, I'm left with 4,530,751. I don't think this divides by 3 again, no, it doesn't. It doesn't divide by 5. Divide by 7. Nope. Did I pick a number that only has a few factors? Not the factor. Oh, I have no idea what the next factor is. I went up to 29 and none of them are working. Okay. That's how you factor. Like I said, you're not gonna have a number that big, and we'll say, and keep going. Testing prime numbers. And that's been an hour, I think we're done torturing.
Thank you.